Hi, we're going to look at folding the paper cup. Now, there's a lot of simple mathematics we can do with a paper cup, and there's a lot of complicated mathematics. We'll start with the simple stuff. I start with a square. I'm going to fold the square into a triangle by folding one corner all the way across this other corner. Now, if your paper is not a perfect square, that doesn't matter. Everything still basically works. At this point, I've got a triangle. I could talk to the students and say, we've got a right triangle, because we've got a right angle up here. Notice it looks like a right angle like this. Often to the students, when I turn it like this, it doesn't look like a right angle the first time they look at it. So having them look at it and recognize, wait, that's a right angle. If we're introducing the word isosceles, we have equal sides here. So we've got a lot of basic vocabulary. Next thing I'm going to do, take this edge right here, I'm going to fold it down to the bottom here. Now, if I talked about right triangles more, we could call this the hypotenuse, and this is something similar to the leg. I'm going to fold this down and match up the edge here. And all I'm doing in this process is splitting this angle at the bottom in half. I'm going to unfold that. I now have this line down here. You don't need to do this with the students, but I'm going to go ahead and draw that line. Okay, so there's that line. What we're doing next, our next fold, is I'm going to take this corner and fold it to touch the end of this line. Okay. Now I'm going to do something else here. I'm going to match the edge of this. I'm going to match the edge of this. I'm going to unfold this. Now, if we look at this shape right here, that's a rhombus. How do we know it's a rhombus? Well, we could actually sit back and see, if I fold this up here, these sides are all the same length. We can see that by folding on top of each other. So the rhombus, the property of a rhombus that's important is all the sides are the same length, and we can physically see it, touch it, create it, and show that it's a rhombus. So we made a rhombus in the process here. We could also talk about perpendicular lines if we wanted to, since these two folds would be perpendicular. So that was a lot of simple vocabulary we could play with in terms of making this cup. Next thing I'm going to do is I'm going to take this corner over here and fold this corner up on top of, lying on top of that. So there's this line right here. I'm matching this line up to this line. Okay. I now have a pentagon. 1, 2, 3, 4, 5. It's not a regular pentagon, so we could talk about regular, irregular. The angles are not all the same. But we can clearly see a simple pentagon. Next thing we're going to do, we also have another triangle on top. I'm not going to take that triangle on top. There's two of them, one in the front, one in the back. I'm going to fold the one in the front, down in the front, and the one in the back behind. I now have a trapezoid. We can clearly see this side is parallel to this side. It's an isosceles trapezoid because this length and this length are the same. So we've got a basic trapezoid. We also have a cup. And I can clearly put things in this cup. It'll hold them pretty well. If I had a locker, I can unfold this one side up here and tape this down so I can have a cup to put things in. It'll hold water. It'll hold about maybe two sips. I mean, I fill it up with water and it'll fall apart in a few minutes, but it's enough to drink out of it. If I wanted to, I could begin to compare this cup, for instance, to a bigger cup. I'm going to do the same thing with a big blue sheet of paper here. Fold it in half. Fold this down, this edge down. Unfold it. Fold this up over here. Fold this on top of this. Again, same shapes. And again, the same shapes do not matter on the size. Could fold this down and fold this down. Now we have two cups here, but they're different sizes. We could talk about the relationship in the sizes, how they match up, how the angles are the same. You know, physically match them to see the angles are the same. but the sizes are different. So even though you make it bigger, the angles stay the same. Again, we're going to see another video with a lot more math on it later, but this is a good start. Thanks a lot.